in this example, the first example in this topic, we need to calculate the length of a curve. And we have 5 minutes to do so. Let's find the length of the curve defined by f of x equals 1/2 e to the x plus e to the negative x. Okay, so find the arc length of a curve defined by f of x equals 1/2 e to the x plus e to the negative x, and we want it from 0 to from x equals 0 to x equals 2. Now look at this function. Do you recognize this function? This function is a definition of the hyperbolic cosine. Right. So one thing we can do is take this function and say, well, this is the hyperbolic cosine, and the derivative of the hyperbolic cosine is the hyperbolic sine, right? And work with that. And actually, this solution is a little bit easier than the solution I'm going to show you. But I don't want to do it now. I may do it on Thursday just to show you how to work with hyperbolic function. But in this case, I'll go straight up, and I know that I need 1 plus f prime squared. Okay, so first I need to find f prime. So if f of x equals this thing, then f prime will be 1/2. The derivative of e to the x is e to the x, and the derivative of e to the negative x is negative e to the negative x. Okay? So one step is done. Now I need 1 plus this squared. So let's square it and add 1 to it and see what we come up with. So 1 plus f prime squared, like so, will be 1 plus 1/2. So we'll square and we have 1/4. And now watch carefully. This is a minus b, so it's a squared minus 2ab plus b squared. So it's a squared, which is the square root of e to the x is e to the 2x. Ravi, join me please. And then minus 2ab minus 2 times e to the x times e to the negative x, and then plus b squared, which is e to the negative 2x, like so. Well, if you look right here, e to the x times e to the negative x is e to the 0, and so it's 1. So you end up having 1, okay, plus 1/4 e to the 2x plus e to the negative 2x. I'll include these, the first and the last, and here I have negative 2, so, but negative 2 times 1/4 is negative 1/2. Okay? All right, I'll push this out. So one more step here, I'll have 1/4. Let's do this. 1 minus 1/2 will be 1/2 plus 1/4 e to the 2x plus e to the negative 2x. And here I'm going to show you a trick. I want to include 1/2 inside this expression. So 1/2 is 2 over 4. So I'll write it as 1/4, and inside here I'll have e to the 2x plus 2 over 4, plus 2, the 4th is outside, okay? So it will be plus 2 plus e to the negative 2x. Okay, there is invisible 2 right here, okay? will be visible in a second. Now, in order to understand what I'm going to do next, okay, let me make it visible too. It's still invisible. Here, there is a 2 here. I'm going to write it as 2 times e to the x times e to the negative x. Okay? You already agreed that this is 1. E to the 0 is 1 plus e to the negative 2x. Now, why did I do something like that? What is it that I'm looking at right there? Very good, Greg. It's exactly what it is. It's e to the x plus e to the negative x squared. Remember, this is inside the radical. This is the radicand. So it is inside the radical. So now I can do the following. L, by definition, is the integral from 0 to 2 of the square root of 1 plus f prime x squared dx. Okay? So in our case, it will be the integral from 0 to 2 of the square root of this expression, right? This is 1/2 e to the x plus e to the negative x, like so, squared. Okay? So it will be simply 1/2 e to the x plus e to the negative x dx. And now this is easy to integrate the entire derivative, of course, of e to the x is e to the x. The entire derivative of e to the negative x is negative e to the negative x. We evaluate from 0 to 2. Okay? And we have 1/2 e squared minus e to the 0, right? Minus let's do it this way. E squared minus e to the negative 2, and then we apply the 0 minus e to the 0 minus e to the negative 0, or e to the 0 like so. Okay? Let's see. 1 minus 1, this goes away, and here we have this result. So it will be 1/2 e to the 2 minus e to the negative 2, like so. Indeed, this is defined as the hyperbolic sine of 2. Okay, good time to stop.